Well, another Sunday morning just after midnight has arrived for you guys, unless you're looking at this later. I know the ones of you that are subscribed get a notification. This is a getting ready for summer AC system primer. I'm going to hit some of the highlights and talk about some stuff here. And I just wanted to make sure that you guys were geared up, ready for the hot weather. POA valve. Incidentally, let me also start out by saying if you fix somebody's AC, whenever they're sweating, they're going to be their hero. That's just the way that particularly is, particularly if you can fix it fairly easily, like replacing a low pressure cutout switch or something like that. But you need to know how to find out what's wrong first. The POA valve is something that was around in the 70s, and it was a complicated way that they came up with, a complicated non-electrical way to control the temperature of the evaporator, and it ran all the time. Now, whenever you turn your air conditioner on defrost, the air conditioner compressor runs by default, even if you don't have the little button push turning it on. And so you want to prevent the evaporator from icing up, because if it turns into a block of ice, then you don't really have any airflow and you don't have any cooling, even if everything else is working right. If there's no air flowing through the evaporator, it's going to get hot in the car. That's just the way that works. Handling the air, this right here is going to be your blend door. Whenever it swings up like this, all the air is going to be coming through the heater core. That's when you got it on warm. Whenever it swings all the way down here, none of the air is going to be going through the heater core. And the reason they call it the blend door is when it's anywhere in between, you're going to get air that's first dehumidified and by the evaporator, and then it's going to have air that's got that dehumidified air is going to pass through the heater core and then go wherever your other part of your system tells it to go. Now, typically, even though a lot of the, beginning in the 90s, because it's very hard to control a blend door that will stop just anywhere you want it to using vacuum, you would basically you're going to have high head pressures and stuff like that. Fan speeds are fairly simple typically. What you got here is whenever you turn it on your you might notice your blower relay is feeding the blower all the time typically, and the ground is what is being fed to the blower through the resistors. The resistors are going to be mounted in the plenum area, so because the airflow is going to go across the these resistors cool them off. If somebody has leaves that get down in there and get laying up against this, they're liable to have smoldering leaves, putting smoke into their into their passenger cabin, because these things, particularly when you're on low, all of these resistors are going to get warm, and because they're slowing the current down that's going to the motor. So that whenever you go all the way to high, then you're typically going to be running the thing, the ground goes straight through the switch to the motor, see? So that's high speed, and when you drop back one, it's going through one resistor. When you drop back two, it's going through two resistors, and on low speed, it's going through all three resistors. And they'll typically have a thermal fuse in there. So fixed orifice system, you got your accumulator here, and basically this is let's see, we're going to start right here because you're going to have a suction line. That's the big line. It goes back to your firewall, pulls it in. This is the discharge line. This is going to be where your high pressure switch is when you have one. Condenser, there's fan blowing over this, and then you got high pressure liquid. It comes to this orifice tube, and then it turns to low pressure liquid. And then as it goes into the evaporator, it evaporates, and as it evaporates, it absorbs heat. The principle is called the latent heat of vaporization, and when this refrigerant turns from, they make sure there's no liquid that makes it the compressor, because if it does, it'll lock it up. So this is high. Notice that if you've got a expansion valve, which is this right here, it's going to be measuring this tube here, and it's going to throttle that refrigerant as it's going in there. It never completely closes up, but it's basically restricting. If this gets too cold, it stops so much refrigerant from getting through here. It sort of throttles it. On some of the Volkswagen Rabbits, they had a screen in this doggone thing, and it would clog up, and it would keep the refrigerator, I mean the evaporator wouldn't get enough refrigerant to even cool the car, ever, because the screen was stopped up in here. But not all of these have a screen. There you got a dryer. You notice the accumulator's gone on this one. If you've got an expansion valve, you're going to have a receiver dryer. And it's in front of the radiator the same way, the condenser. Hondas and some of the Dodges, it's kind of brilliant, I think, have the compressor. This is a little bit of a rundown on the way the difference right here between the accumulator and the receiver dryer. You know, some of these had a sight glass on them, but that sight glasses are pretty much gone, you know, where you could look at the refrigerant flowing through there and make sure you see when it was full, it didn't have any bubbles in it. Now, if you might notice from the evaporator, this refrigerant goes in here. There's a desiccant bags in here, and there's a puddle of refrigerant and oil in here. This mix is kind of like, if you know, like a Dr. Pepper or something, it's all mixed in here. If you release pressure, then it starts, the refrigerant starts bubbling out of this oil. Now, there may not be that much oil in there. I think there's too much oil residue, but there's a screen here. And so all of this gaseous refrigerants in the top part of this thing is going to be drawn in here to go together there. The expansion valves change the size of the liquid line orifice based on the temperature of the suction line as it leaves the evaporator. You see this right here. That's one that we put on a Toyota Camry right there. There's an expansion valve right there. It's measuring the temperature of that line. If this is not connected to this line, or if it comes loose from it, then this expansion valve is going to not work right, and you freeze the evaporator and do crazy things like that. And I basically got this drawn right here, you know, so basically this little alcohol tube, whenever this alcohol expands and contracts, it basically moves that little orifice to control the, it's, you know, it's carefully calibrated. Looks like that, you know, whenever you're seeing one, or here's another picture of one right here. But you got a block TXVs, which is more common. You know, basically you got that thing, you got to take the line loose from it. It's got some little screws that holds it to the evaporator. You got seals in between there. You got to make sure you got good seals and gaskets and all. It modulates refrigerant flow. This does the same thing, but what you're looking at here is it's measuring it right there in the house. You see the big suction line and the little liquid line? Since it's measuring it there, it actually controls this all in one piece. You can see how that little alcohol thing, it actually is going to open and close this right here. So that's why they don't call it a fixed orifice. If your thermal expansion valve is bad, you know, you're probably going to see low pressures on both sides, even when you know you got the right charge. Let's say you got low pressures, you use your machine, you extract the refrigerant, and then you charge it back up with the proper amount. You know, the really nice machines don't have to have the engine running to charge the refrigerant. Of course, if you're using a can, you're going to connect it to the basically the low side. And my Jeep one time had a leak or something that I wasn't aware of, and I noticed I was driving it and it was getting hot, and I was on a trip. So I stopped and I bought a can of refrigerant, because that Jeep only held 1¼ pounds. It was a 2001 Cherokee. Off on a tangent. Orifice tube is mounted in the liquid line, but it can be anywhere in that line. On some vehicles, you had to replace the entire liquid line to replace the orifice. It's usually going to be fairly close to the evaporator, but not always. On some of the older Chevrolet pickup trucks, you had to take the grill off the truck, and the the orifice was right there on the out there by the condenser. And a lot of the times on those, the lines would be galled, and you start to try to take it off, the lines wouldn't come off, and you wind up messing up threads because the lines were galled, and you'd have to replace things, and it was a bear. But this is a video I saw at Mobile Air Conditioning Society of a variable orifice valve. I don't know where you'll find these or how many vehicles have them, but I thought it was very interesting that they're trying to get the best of both worlds out of this. It ain't that complicated. You can watch that video. like doing that. I like to put one in there the right color. Orifice tube systems have low pressure cutout switches. They usually cut the compressor off when the low side pressure drops below a certain threshold, usually about 25 psi. If one is short cycling, and you know, if you got normal ambience out here like 80, 90, 100 degrees or whatever, it ought to run the compressor just about all the time. If you turn the thing on max, close the doors, max AC, that's recirculating the air inside the car, low blow, a properly operating system, even on a good hot day, 85 or 90 degrees, ought to cycle the compressor off and on. Now, I always like to hold the engine speed up to about 1500 when I'm checking this, so that the compressor is really doing its work well. And as it cycles off and back on, you know, it's going to, the cold, you know, pressure and temperature are going to be related. All right, your high pressure cutout switch is basically going to, you know, that's something that back whenever we had the R12 systems, you didn't usually have a high pressure cutout switch, although sometimes some of them did, and if they did, it would be in the here, and it was for the most part just measuring temperature, but it would cut out the, I call it a high pressure cutout switch, but basically this works on temperature rather than pressure. And the compressor would come with this little plug in there, and if you had one of those on the system, you needed to take this snap ring out, get that out of there, and put this in there with a new O-ring, and you know, snap ring it back in there. They're either wired in series with a low pressure switch. See this one right here, this is on a Jeep. Whenever this high pressure kicks on, this is a dual function, it's a ganged switch, and it also does fan request. So the powertrain control module, when this high pressure switch click, not only, see what, this is normally closed like that, and this side of the switch is normally open. Whenever you got high pressure, this snaps over here and opens up the AC switch. In other words, it's like the AC, it's like you turned off the air conditioner, and the radiator fan comes on, and whenever it cools that condenser down, then this switch clicks back, turns off the radiator fan, and then you wind up with that. Low pressure is going to cycle it the same way. See how it's wired in series? But look at this, cutout switches. This vehicle downsized. The feel of the compressor switching off and on tended to be annoying. I showed you how that in one of my other videos, how my diesel Rabbit, when the air conditioner kicked on, it felt like you threw something under the wheel to slow you down. And so I used that little the little switches on the injector pump that, you know, that were tell you when you were at different, they were basically made to help it turn that light on so you know exactly when to shift for optimum fuel economy. But I used the wide open throttle switch on that to operate a relay to drop the compressor out when I was at wide open throttle. That was a modification I made to give me a little more power accelerating on that diesel Rabbit, you know. The accelerators got smaller, compressors got smaller and lighter. These don't take as much power to turn. These compressors like to fail though, and that's nasty. This one right here is variable. It actually moves that plate, and whenever this plate's vertical, the pistons aren't moving back and forth at all. It can change that, you know, in increments so that it can compress more or less. This one does not have a compressor clutch. It spins all the time. And this one right here is the old, this plate always has got the same angle, and it whirls around there, and those pistons go back and forth the same amount. It's turned on and off by your cycling switch or whatever. The variable displacement compressor was born to reduce the load on the engine. There's no clutch, but the pulley is designed to break away and free the wheel if something locks up. Now, anytime the engine runs, it's direct drive. But like I say, it's going to control piston stroke. When this is vertical, the pistons aren't moving laterally, right? So the more of an angle you put on it, the more the compressor compresses. You know, so you got you little, you know, some of them are mechanical, some of them are electrical. You know, PCM control is the way that everything's favored over here. Pulse width modulation. Wobble plates versus swash plates. Oh, axial style compressors have been around since the early 60s. Little big old huge thing. And we've got it to the point where we can actually watch what happens when we spin it. You notice it's got 5 pistons over here and 5 pistons over here, and they run off a swash plate in the middle. So when we spin that thing, we got pistons going both ways. All right, so now that we got pistons going both ways, on each end of this thing, we've got these plates here, and they've got little flutter valves in them. And those flutter valves let it pull air in, and then they push it back out. And so that's basically the operation of the air conditioner compressor. Figured y'all would enjoy that away from that. On your variable displacement compressors, you got this variable angle wobble plate. Now I took this picture at the Ranshoe booth at the Mobile Air Conditioning Society here, so this picture is actually a snapshot that I took with my own camera, so I didn't steal it from anywhere. If you see this same picture anywhere else, somebody borrowed it from me. And since I review articles for carparts.com, I've used this on their website too. But some of them are internally controlled, some are externally controlled, some are electronic PCM controlled, some are pressure controlled, but they all basically are going to change the angle of this plate to change the stroke of those pistons to change the way the compressor operates. When the wobble plate's nearly 90 degrees, the relationship to the input shaft, it's very little wobble. As the compressor spins, they only make a very slight movement back and forth. So the desired angle of the throttle plate is controlled by the valve in the backside of the compressor. And you can kind of see that little animation I put together right there. That's a simplified version of it, and basically a land art form. Variable displacement compressor wobble plate gets stuck or anything locks up, then it will break. These things will break away. Now sometimes, from what I'm told, these things will break away even when there's nothing else wrong. And so anyway, it'll shear these little breakaway connections is what it does. They wanted to give it something it could do, if something went wrong. So if the compressor's noisy, the pressures are weak, or see the pressure's over here. If you got pressure that's too high and pressure that's too low here, that's typically going to be a weak compressor just about every time. Now you need to make sure you got the right amount of refrigerant in there. You need from 70 to 100 pounds of static pressure. Now all of these pressures are going to be higher if it's really hot outside, the pressures are going to be higher than it is if it's cold outside, and it's going to short cycle more in the winter too. Or if it's a cool fall day and you're just running it because of the greenhouse factor warming the inside of the car through the glass. If you got your air conditioner on, you may hear it short cycling. I mean it's low on refrigerant. It just means that the ambient temperatures are lower, and it's dropping below that threshold more often. Anyway, I always just use needle nose. I had a special tool, but I didn't use it all that much. The PID for compressor displacement solenoid is displayed on the data stream in current. That corresponds to the average cycle time of the solenoid, and the diagnostic trouble code sets if the pressure is not matching the commanded state. This is that closed loop thing. It makes a command, it looks to see if it's being, if the conditions it's calling for are being met. If they're not, that's your closed loop, kind of like closed loop fuel control. Compressors, PCMs have closed loops all over the place, but the one you think about the most is the oxygen sensor stuff. Electric compressors are standard for most hybrids. 05 to 09 Escape, Mercury, Mariner have mechanical compressors, but some Hondas used a compressor that was 2/3 mechanical belt driven, with the remaining rear third being orange cable high voltage. So you got to use the right kind of oil. If you put the wrong kind of oil in there, it will basically melt the stuff off, the insulation off the winding inside the compressor, and it will cause it to short out and all that kind of thing. Now you see orange cable going to that thing, that's your high voltage on all them hybrid vehicles. 12 volts fine for an electric water pump, but not for powering an AC compressor. Electric compressors run on 100 volts, at least over 100 volts. They're powered by the high voltage battery, and they can run with the internal combustion engine off. A slight growling sound from the high-speed motorized compressors is normal, so the engine doesn't have to be running for the compressor to operate. My 2025 Ranger's got auto start stop, and in the hot weather, whenever the engine shuts off at a traffic light to save gas and all that, what it'll do is if the AC system detects that it's starting to warm up in there a little bit, it'll start the engine up to keep the AC going. So it's pretty smart on that. But this is, there's a scroll. These, you can look at stuff to tear down and play with. refrigerant capacity is not nearly what it used to be. Most systems now take less than a pound of refrigerant. The R1234, which I didn't talk a lot about right here, but it's basically expensive enough that you better make doggone sure as much as you can if you got your leaks fixed, because if you're having to put a 40 or 60 or $80 can of R1234 in there every couple of weeks, the cost adds up. Now I am putting together a test on this for the next couple of weeks. I probably may have a couple of these A5 tests, and I mean A7, not A5, unless I got those numbers crossed up. A7. Let me see that. Yeah, I have to use my my ASC certification to make sure I'm giving you the right numbers here. All right. Now this is a chart I put together for my students, and you can freeze this, save it, print it, whatever, and this is pretty much going to point you in the right direction. I also put together one of these for about Ford Cruise Control back in the day, for my guys in the shop over there. But anyway, you can look at this, and I'm not going to go through all this because it takes too much time. We've already been here 30 minutes, and some of you guys probably already dropped out if you got a little short attention span. But that pretty well winds us up on this air conditioner primer, and I hope you guys really enjoyed this video. I hope you got a lot out of it. Let me know what you think, and share it with your friends. We'll talk to you next